Hello, you're welcome to this lesson. In this video, I'm going to learn about interpolation. Okay, so now let's look at what interpolation is. So many times data is given only at discrete points such as x0, y0, x1, y1, all the way to xn minus 1, yn minus 1, and then xn, yn. So how then does one find the value of what y at any other value of what x? Okay, so assuming you have discrete data points, okay, x naught, y naught up to what x and y n, and then you want to find the value of what y at any other value of what x. How then do you do this? Okay, so to do this, what we do is that we normally represent the data point with a continuous function f of x. Okay, so when we do this, we make sure that this function passes through all the given data points. Okay, when this happens, then we will be able to find the value of what y at any other value of what x. Okay, this is what this means. Okay, so what type of function do we choose then? Okay, so normally we choose polynomial functions, which is because they are easy to evaluate, differentiate, and also what integrate. Okay, so that's why we choose polynomial functions. So what we do is that we find a polynomial function for the given data point. Okay, and then this polynomial function will pass through all the given data point. Okay, and then for that reason we'll be able to find the value of what y at what any other value of what x. So if you look at this figure that I have here, we have some data points from x0, y0 up to x3, y3. Okay, and then we represented the data point with a function of f of x, which is what a continuous function that passes through all the given data points. Okay, so when this happens, if you are given any other value of what x, okay, we can trace it to the continuous function to get its corresponding what y value. This is what this is about, but we normally use what polynomial functions. Okay, so at a point where you are let's say you are given data point, okay, and then let's say we are given x values and then y values. Okay, so for x equals 1 we have y to be 3, for x equals 2 we have y to be 4, and then for x equals let's say 4, okay, we have y to be 6. Okay, and then let's say I want to find the value of y when x is equal to what 3, because I didn't give the value for what x the value of what y for x equals 3. So how then do we do this? So this is what interpolation is about. So we use interpolation to find the value of y when x is what 3. Okay, and we normally use what polynomial functions since they are easy to what deal with. So out of me wanting to find the value of y when x is equal to 5. Okay, so in this case 5 is not actually within the range that I gave from 1 to 4, right? And I wanted to find 3, and then 3 is within the range, but in this case 5 is not within the range. Okay, so in this case we are going to call this extrapolation, okay, which is what you have here. So if the value of x doesn't fall within the range that you have, we call it what extrapolation. Okay, so polynomial interpolation involves finding a polynomial of order n that passes through the n plus 1 data point. One of the methods of interpolation is called the direct method, and then we have other two methods known as the Newton's divided difference polynomial method and then the Lagrangian interpolation method. Okay, so these are some ways that we can perform polynomial interpolation. Okay, but in this video I'm going to focus mainly on the direct method of what interpolation. So I'm going to explain to you what the direct method is, and then we solve some two examples for us to better understand this. So let's go ahead. Okay, so now let's look at the direct method of interpolation. Okay, so the direct method of interpolation is based on the following premise. Given n plus 1 data points, fit a polynomial of order n as given below through the data where a0, a1 all the way to an are n plus 1 real constants. Since n plus 1 values of y are given at n plus 1 values of what x, one can write n plus 1 equations. Then the n plus 1 constants, which are a0, a1 out to an, can be found by solving the n plus 1 simultaneous linear equations. To find the value of y at any given value of x, simply substitute the values of x into equation 1. Okay, so let me explain this to you. So if you are given n plus 1 data points. Okay, if you are given n plus 1 data points, okay, all you have to do is to fit the n plus 1 data points into a polynomial of order what n, okay, of order n, given as this function that we have here. When you do this, okay, we now know that the data points are fitting towards this polynomial equation of order n. Okay, when you do this, you'll be able to find the value of what y at any other given value of what x. Okay, so let me explain the n plus 1 data points to you. So let's say you are given 6 data points. Okay, if you are given 6 data points and then applying the n plus 1, that is the same as what uh, that is the same as what 5 plus 1 data points, right? So in this case, our n will be what 5. Okay, so our n will be equal to what 5. So if you are given 5, if you are given 6 data points, that means what you are going to use what a polynomial of what order 5, right? When you use this polynomial of order 5, all you are going to do is that you are going to consider all the given data points. Okay, so you consider each x and then the corresponding what y value. Okay, so when you do this, you are going to have some equations, okay, which contain the constant. Okay, so when you get these equations, you have to solve all the equations, okay, to get what the unknowns. Okay, so when you get the unknowns, then you come and substitute them into the general formula. The unknowns will be the a naught, a1 up to what the an. So when you get the unknowns, you substitute it into the general formula to get the polynomial function for that given data point. Okay, so that's what this means. Okay, so let me make a simple example. Let's say you are given 2 data points. Okay, so if you are given 2 data points, that's the same as what 1 plus what 1, right? That means that you are going to use a first order polynomial function, right? So from the general function, we have y equals a naught plus a1 multiplying x, right, plus a1 x squared, okay, plus all the way to plus an xn, right? So this is the general formula, right? So this is what an nth order polynomial, but in this case, I've given you a 1 plus 1 data point, which means that our n is what 1, right? So in this case, we are going to use what a first order polynomial. Okay, so if you are using a first order polynomial, then that means what our n must be what 1, right? So which is this one here. So you're going to have y to be equal to what a naught plus what a1 multiplying what x to the power what 1, right? There's 1 there, but it's not really necessary for us to bring it. So if you are using a first order polynomial, then this is the polynomial function that you are going to use, because we are given what 2 data points. Okay, so in this case, if you are given 2 data points, let's say for the first data point, let's say x naught was equal to 1, and then y naught was equal to 2, and then x1 was equal to 2, y1 was equal to, let's say, 3. Okay, so if I'm giving this data point, okay, we can group them as 1 2. Okay, this is my first data point, and then 2 3. Okay, so I have 2 data points. So if I have these 2 data points, I would like to find a polynomial function that will fit these 2 data points. Okay, so what I'll do is that I'll go to my first order polynomial function. For the first value of y, we have 2, so we are going to have the first equation to be 2 equals a naught, okay, plus a1 multiplying what x naught, but our x naught is what 1, so we are going to have what a1. Okay, and then for the second equation, the y is 3, so we are going to have 3 equals a naught plus what 2a1. Okay, so when you do this, we have these 2 equations. Okay, so now that we have these 2 equations, we can solve for a naught and then a1. Okay, so when you solve for a naught and a1, we are going to get our general polynomial function. Okay, so when you get our general polynomial function, any value, okay, any x value within this range, in this case the x values are 1 and then 2. So when you do this, any x value within this range, okay, can be put into the general formula to find its corresponding what y value. Okay, so this is what this means. And then mind you, you see that we have a first order polynomial, right? In the example that I was making, and then since it was first order polynomial, we considered up to this point, right? And then if you look at that point, we have two constants, which is what a naught and then what a1. And then since we have two constants, that should tell you that then you are going to need what two equations. Okay, so if you have two equations, then we can solve for the two unknowns. Okay, or even if you have two data points, just know that you are going to have what you are going to have what two equations. Okay, if you are considering two data points, you are going to have what two equations. If you are considering three data points, you are going to have what three equations, so that you can solve for the what three unknowns. Okay, so I'm going to solve this, okay, with an example so that we better understand it. Okay, so I have the question here. The question says the upward velocity of a rocket is given as a function of time in table 1. So this is table 1 that we have here. Okay. The question says determine the value of the velocity at time 16 seconds using the direct method of what? Interpolation and then a first order polynomial. Okay, so now let's focus on this. The question says we should use a first order polynomial. That means what? Our n is equal to what? 1, right? So in that case, we will need what? A 1 plus 1 data point, which will be what? 2 data points. Okay, so we will need 2 data points. Okay, so let's go ahead. So now the question says we should use what? Two data points. Okay, so if you're using two data points, you're going to have linear interpolation, and then this will be the graph for the two data points. You have x naught, y naught, x1, y1, and then this will be what? The linear function. Okay, so now let's look at what you are going to do. Okay, I don't know what's going on here. Okay, so you are going to need two data points. Okay, and then the question says you should find the velocity at what time? What 16 seconds? Okay, so looking at this data point that we have here, 16 is going to be within 15 and then 20, right? So the time value will be within 15 and what 20. So our two data points should be 15 and then what 20. Okay, the x value, which in this case is still should be what 15 and what 20, because that's the range that the 60 seconds what falls. So we are considering what a first order polynomial, which means that our n is going to be 1. So from the general formula we have y equals a naught, right, plus a1x plus a2x squared, okay, plus all the way to plus an xn, right? But in this case our n is equal to 1, okay, which means that we are going to consider all the way to this point, because that's the point where x is equal to 1. Okay, so our polynomial function will be of the form y equals a naught plus what a1x, and I took that because we have two constant, that should tell you that we are going to need what two equations, and then that confirms the fact that we need what two data points. So let's look at the data points. Okay, so we have t naught, okay, to be equal to 15 seconds, and then v of t naught to be equal to 362.78, okay, and then we have t1 to be equal to 20 seconds, and then v of what t1 to be equal to 517.35. okay, so those are the data points. Okay, all right, so now let's get our equations. Okay, let's get the equations. Okay, all right, so we have the general to be we're going to have v of t, okay, because our y is now v of t. Okay, so we're going to have v of t to be equal to a naught, okay, plus a1 multiplying what t. Okay, this is the general formula that you are going to use. Okay, let me rewrite this again. This looks too thin. Okay, so you are going to have v of t, okay, to be equal to a naught plus what a1 multiplying what t, right? So you have the data point. Okay, you have the data point, so let's consider the first data point. you have t naught to be 15, and then v of what t naught to be what 362.78. So for that one, you're going to have the first equation to be 362.78, okay, equals a naught plus a1 multiplying what t. So we're going to have what 15 multiplying what a1. This is our first equation. And then the second one, we are going to have 517.35, okay, to be equal to a naught plus 20 a1. This should be our equation 2. So all you have to do is to solve these two equations simultaneously to get the value of what the constant a naught and then what a1. Okay, so let's solve these two equations. Okay, so for these two equations, it depends on how your lecturer wants to solve it. Okay, so the lecturer might give you a specific method, because you know there are several ways to solve these two equations. So depending on the one that your lecturer wants you to use, you just have to go ahead and then use it. But I'm going to use a calculator to solve these two equations. Okay, so let's look at how I'm going to do this. So you press mode on your calculator, you choose the fifth option, which is equations, and then you have two equations with two unknowns. So you're going to choose the first equation, and then the coefficient of a naught is 1, that of a1 for the first equation is 15, and then that's all equal to 362.78. Okay, and then let's go to the second equation. The coefficient of a naught is 1, that of a1 is 20, and then this will be equal to 517.35. So let's solve these two equations. When you do this, you are going to get a naught, okay, to be equal to minus 100, okay, point what 93, and then you're going to get a1 to be equal to 30.914. Okay, so now that you know the value of a naught and then a1, we can substitute into the general formula that we have. So you're going to have v of t to be equal to minus 100, okay, 0.93 plus a1, which is what 30.914 multiplying what t. So this will be the polynomial function, okay, of order 1 that will pass through the two data points that we considered, because the question says we should use what a first order polynomial. So now that you have this, you've been given time t equals what 16 seconds, and then that's within the range that we considered. So let's substitute the value of what t equals what 16 into this equation that we have here to find the value of what the velocity at that particular time, what 16 seconds. So let's go ahead. Okay, so at time 16 seconds, you're going to have minus 100, okay, 0.93, okay, plus 30.914 multiplying 16, okay, multiplying what 16. Okay, so let's simplify this and see what you're going to get. So you have minus 100.93 plus 30.914 multiplying with 16. This will give me a value of 393.694. Okay, so this is what it means. So let me explain this whole thing to you. So we have a data point. Okay, we have data point which has been given in this table here. Okay, and then what we are asked to do is to find the velocity at time what 16 seconds. But from the given data point, we don't have what time 16 seconds is there. So the only way to get that is to use what interpolation. Okay, and the question says we should use what a first order what polynomial. Okay, so you know that normally interpolation we are dealing with what polynomial function, because they are easy to what evaluate, integrate, and then differentiate. So that's why you're using what polynomial function. So our main goal is to find a polynomial function that can fit into all these given data points. Okay, but the question was specific. It said we should use what a first order what polynomial, which means that what our n will be 1, and then for that reason we are going to have what 2 data points. And then for the definition, you know that if you have n plus 1 data point, then you are going to use what an nth order what polynomial, right? That's why we use what a first order polynomial. Should it be that you are considering all these data points, okay, to get our general polynomial function, then that means you're going to have what? How many data points do we have? We have 1, 2, 3, 4, 5, 6. We have 6 data points. So in that case, you're going to use what? A fifth order what? Polynomial function, right? Because you have what? 6 data points. You are going to use what? Uh, a fifth order what? Polynomial. Okay, so let's take note of that. So in that case, all you have to do is to consider all the data points because you have what? A fifth order polynomial. But in this case, we were using just a first order. Okay, so that means what? Our n is 1, then we need just what? 2 data points. Okay, but if our n was 5, then that means what? You are going to need what? 6 what? Data points. Okay, so you should take note of this. So from there, all you have to do is what? Find your polynomial function that will go into the data point. After doing that, you solve for the unknown constant. Okay, then after solving for the unknown constant, you substitute it into the general polynomial function to get what? The polynomial function for the given data points. Okay, so let's take note of that. Okay, so let's take another example with this same question. Okay, let's say we are using a second order polynomial. Okay, let's say you're using a second order polynomial, so let's take note of that and then do this. All right, so this same example, you're using a second order polynomial. Okay, so not first order again, second order. Okay, if you're using a second order polynomial, that means what? Our n is equal to what? 2. So therefore you're going to need what? 2 plus 1 data point, which will be equal to what? 3. So in this case, you are going to need what? 3 data points. And then you want to find the time at what? 16 seconds. Okay, so let's consider the data point so you can have what? 16 seconds in between. So in this case, you can consider from 15 to what? 22.5 because you're going to have 16 there, or you can consider from 10 to what? 20. We are still going to have what? 16 there, so it depends on the one that you want. Okay, so in this case you have we are using a 3 data point. Okay, so I'll consider from 10 to 20. Okay, so let's take note of that. Let me clean what I have here. So you're considering 3 data points. Okay, from 10 to 20. Okay, so you're going to have t naught to be equal to 10. Okay, and then v of t naught, okay, that should be equal to 227.04. okay, and then we are going to have t1, okay, to be equal to 15, and then v of t1 to be equal to 362.78. okay, and then we have what? V of what? Sorry, you're going to have t2 to be equal to 20, and then v of what? T2 will be equal to 517.35. okay, so those are our data points. Okay, so you're using what? A second order polynomial. Okay, so let's look at how you're going to go about this. So the general formula is of the form y equals a naught, right, plus, okay, a naught plus a1 x, okay, plus a2 x squared plus all the way to plus an xn, right? But in this case, you're using a second order polynomial, which means what? Our n is what? 2. So in that case, you are going to what? End here. Okay, so let's write the general formula for this question. That's going to be our y is now v of t. So I'm going to have v of t to be equal to a naught plus a1 multiplying t plus what? A2 multiplying what? T squared. So this will be the general formula for what? This question. So all you want to do here is to find the value of what? A naught, a1, and then a2, and then there are 3 unknowns, which means that you're going to need what? 3 equations, and then of course that can be confirmed by the number of data points that we are using. Okay, so now let's go ahead. So let's generate our equations. Okay, so now let's generate the 3 equations. Okay, so for the first one, we're going to have our v of t to be, we're going to have 227.04. That should be equal to a naught, okay, plus a1 multiplying t. Our t in this case is the t naught, which is what? 10. Okay, so let me make it 10 a1, okay, plus 10 squared, okay, multiplying what, a2, okay. This is what you are going to have. Okay, so this will be the first equation, okay. This will be the first equation. Let's consider the second equation. You're going to have 362.78, okay, and then that should be equal to a naught plus 15 a1 plus 15 squared a2, okay. This should be the equation 2, okay. And then we're going to have 517, okay, 0.35 equals a naught plus 20 a1 plus 20 squared a2. This is our equation 3. So you just have to solve these three equations simultaneously, okay. So let's look at that. 10 squared will give us a value of 100, okay, and then 15 squared will also give us 225, okay, and then 20 squared will also give us what, 400, okay. So we can do the substitution, okay. So after doing the substitution, then you solve the three equations simultaneously. So let's solve the equations simultaneously to find the value of what, a naught, a1, and then what, a2, and then substitute it into the general formula. So I'm going to do this using the calculator, okay. So let's go ahead. So you press mode, you go to 5, which is the equations, and then we have 3 unknowns here. So I'll choose the second equation. Okay, so let's input 1, 10, 100, okay, and then that's equal to 227.04. Then have 115, 225, that's equal to 362.78, okay. And then have 120, 400, and then that's equal to 517.35, okay. So after solving all these three equations simultaneously, we got a naught to be equal to 12.05, and then a1 to be 17.733, and then a2 to be 0.3766, okay. This is what you have. So now let's substitute all what you now have into the general equation. Okay, so now let's go ahead. So we have our general equation to be v of t equals a naught plus a1 multiplying t plus a2 multiplying what, t squared. So now we know the value of a1, a naught, and then a2. So let's do the substitution. I'm going to have v of t to be equal to 12.05, right, plus 17.733 multiplying t, okay, plus 0.3766 multiplying what, t squared. So now you can find the velocity at what time, what, 16 seconds, using the general formula that we have. So I'm going to have v of 16, okay, to be equal to 12.05, right, plus 17.733 multiplying what, 16 plus 0.3766 multiplying what, 16 squared. So let's see what you are going to get. So I'm punching everything straight for it. 12.05 plus 17.733 multiplying 16 plus 0.3766 multiplying 16 squared. That will give us a value of 392.188, okay, meters per second, okay. So that'll be the value for the velocity at what time, what, 16 seconds, okay. So this is the answer you get when you are using a second order polynomial, okay. You can also solve this using a third order polynomial and so on, okay, up to the number of data points that you have. So this is how to apply the direct method of what, linear interpolation. Thank you very much for watching this video. If you find this lesson useful, please consider liking the video and subscribing to the channel. Thank you.